Okay, now we finished polar equations and polar graphs. What we're going to move into now is vectors, and we're going to kind of look at a very shallow look at vectors. This will help you if you're going into AP Physics or on-ramp physics next year. So with vectors, I'm going to kind of explain it a different way than I've ever explained it before, and I actually like this explanation. You learned in geometry that you had a line, and this line, let's call this PQ, and this was line PQ. Line PQ, and we know uppercase letters are points, and we put the line above it for line PQ. And we know that there is an infinite amount of distance. We can't measure the distance of a line because a line is an undefined term from geometry. Then we have what we call a line segment. We can do a line segment PQ. And then we would note this as just a bar with a capital P, capital Q. Once again, your points are capital letter for P and Q, and then just the segment part. But we had what was called the ruler postulate, where now we have an actual distance. We can call that D. So this is actually a distance. You can actually measure a distance from PQ. In fact, we even had the distance formula, which was D equals the square root of our x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And you learn in geometry that that comes from the Pythagorean theorem, where your D could be x squared plus y squared. You take the square root of it. So we've learned you learn all of this in geometry. What we're going to do is we're going to take a vector and we're going to build on this idea. So we're still going to take a line segment PQ. So PQ, except now I'm going to give it direction. So now it's going to have a distance. We're going to call that distance magnitude for a vector, but it means the same thing. It's the distance or the magnitude. But now I've got a direction to this. So there's two ways that you can do this for notation. You can do it as PQ with array, but this is ray PQ, and I don't really like that notation because it can be confusing if you understand geometry. So what I do, and you may see it this way, and this is how you'll see it on mine, is you're going to see kind of like a harpoon. Instead of a full arrow, I'm only going to do like the top part of the arrow, and this tells you that this is vector PQ, starting at P, and it's going to end at Q. So we start at P and we go to Q. This also has a distance because it has the line segment aspect to it, and it has direction. So a vector has distance and magnitude, or direction and magnitude. We have the direction and we have the magnitude, the distance. That's what a vector actually is. Now from this, it opens up a realm of possibilities that we can actually use to solve a lot of different problems. But the first thing we're going to do is we're going to look to see how we can go from 2 points, like point P and point Q, and write it as a vector. So let's look at that now. All right, so I have 2 points here. I have point P, which is 7, 4, and point Q, which is -3, -6. So if I were to graph this, it's going to look, let's see, P is 7, 4, so over here, up here somewhere. So we'll call this P, capital letter, because it's a point. Q, -3, -6, down here somewhere, capital letter, because it's a point. Now because we're going to P to Q, we're going to draw in an arrow, and there's my vector. All right, so that's graphically the vector itself. But I need to have a mathematical way of actually finding these vectors. And what we're going to do is we're going to go tip minus tail. So we're going to do tip minus tail to find my actual vector. And now we're going to talk about two different types of vector notation. The one that I will use in this class is going to be where we're going to, instead of doing parentheses for points, we're going to do these angled brackets. So what I'm going to do to find the x version, the x for my vector, is I'm going to do my x value minus my x value, my tip of the vector to the tail of the vector. So -3 minus 7. And then for my y component of the vector, I'm going to do tip minus tail, so -6 minus 4. And then I'm going to close it off with the angled bracket. So this will end up being, let's see, -3 minus 7 is -10. -6 minus 4 is -10. And that is your vector PQ. So this would be vector PQ. Vector PQ. Easy enough. The other way you can write this is with the I, J, and K, but we won't deal with the K. I means is the X value, J is the Y value. So I could write this as negative 10I minus 10J. You will see that in physics, IJ, and then later on K, which is the Z component. So I is your X, J is your Y, and K is your Z. IJK, X, Y, Z. I don't know why they picked IJ and K for that. I'm sure there's a reason. Not a physics guy, I'm a math guy. But we're going to use this one here, but do not write it with curved parentheses, because at that point it's either going to be an interval notation or it's going to be a point. A vector is going to have these angled brackets. This is the X component of the vector. This is the Y component of the vector. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.